Hi, grade 12s. We're going to start our trig today after all of your algebra and polynomial equations. I'm sure this will be a welcome relief. We're just going to review and preview, first of all, different types of triangles. We know that in any triangle, the sum of the interior angles is 180 degrees. And we know that a straight line, which could be made up of C and let's call this obtuse angle D, would also be 180 degrees. So we have this exterior angle theorem that angle D is the same as A and B together, all from the sums of 180. So that can be helpful sometimes as well. We have different types of triangles. If we have two sides similar, we have an isosceles triangle. And that allows us to mark equal angles in the bottom two corners. An equilateral triangle has all three sides the same, and therefore all three angles. All three of those angles would be 60 degrees. Right-angled triangles, these are the ones we use most often for trigonometry. We find that in real life a lot. Verticals and horizontals, straight, right-angled triangle. Right-angled triangles have the longest side called the hypotenuse. I can't remember if hypotenuse has an E in it. Let's go with E today. We have Pythagorean theorem that we can use with right-angled triangles as well. The hypotenuse side squared is the sum of the other two sides squared. Acute angled triangles, all three that we've been talking about have been acute angled triangles. Honestly, the easiest way to remember that is that it's acute. All of the angles are smaller than 90 degrees. An obtuse angled triangle has one angle that's larger. If you call somebody obtuse, that means they're being ignorant. So if that helps you remember, obtuse angled triangle, one angle larger than 90. Some words that we use from time to time: supplementary angles are angles that add to 180. In other words, they form a straight line. So angles A and B are supplementary angles. They form a straight line, and if we knew their degree measure, they would add to 180 degrees. Complementary angles add to 90. They form a right angle. So this angle A and B, whoop, there, form a right angle. They would add to 90 degrees. Pythagorean theorem we mentioned already. C squared equals A squared plus B squared. Be careful to set that up always that the hypotenuse or longest side is by itself. So for this one, we're going to put numbers in where they belong and solve for x. My longest side is the 9.5. So 9.5 squared equals the other two sides squared, order doesn't matter, 6.2 squared plus x squared. If I want to solve for x, I need to get x by itself. So x squared, I have my 9.5 squared minus 6.2 squared, and I need a calculator. 9.5 squared, take away 6.2 squared on my calculator is 51.81. I haven't rounded yet, but I'm going to take the square root of both sides, and since I am considering a length, I don't have to think about the negative answer. I just take the positive square root of 51.81. And I have I'm going to round to 1 decimal place, 7.2. The reason I chose to round to 1 decimal place is that both of my measurements were to 1 decimal place. So giving it any greater accuracy than 1 decimal place would just be silly on my part. As a reminder, we're going to have to be solving some equations, and none of them are going to be anything like what we did in the last unit. But just as a refresher, we should record some things that we might see while we're working with trigonometry. For the first one, I want to solve for x, and I just need to isolate the variable by doing the same thing to both sides. So if I want to get x by itself for number 1, I want to get rid of that add-on first. I'm going to subtract 7 from both sides. If it helps you to make a little note to yourself of what you're doing, go for it. Lastly, I want to get rid of the 3. 3 is multiplying by x, so to get rid of multiplication we divide. So I am dividing both sides by 3. Done. Best answer. The second one, I have a ratio. X divided by 26 equals 12 divided by 39. To get x by itself, I want to get rid of divide by 26. So I'm going to multiply both sides by 26. That will effectively get rid of divide by 26. So my right side will be 12 times 26 divided by 39. And that will be 8. There. X squared plus 300 equals 525. We could subtract 525 from both sides and factor. That's one way to solve that. Another way to solve that is to use the powers that we did in the last unit. We're going to subtract 300 from both sides. That leaves us with x squared equals 225. Since I don't know whether x is a distance or not, it is possible that a negative answer would make sense in the context of this problem. So when I impose a square root, I get x squared equals the square root of 225. But I should remember there might be a positive answer and there might be a negative answer. Square root of 225 is 15. So I have two answers. X could be 15 or x could be negative 15. And both of those make sense. When you square 15, you get 225. When you square negative 15, you get 225. Two answers. And lastly, trigonometry, where we have principles discovered with right-angled triangles. And that's where we're going to start with right-angled triangle trig. So SOHCAHTOA and Pythagorean theorem are our two tools with right-angled triangles. With SOHCAHTOA, it's a little memory device to help us remember the names of the three trig ratios that involve opposite, adjacent, and hypotenuse sides. So what we need to do is rewrite these angles so that we have ratios in front of us that make sense. I'm going to call my angle of reference theta. So the angle that's important in this particular triangle is theta. I either know it or want to know it, and I'm going to label my sides accordingly. The hypotenuse side is always the longest side. For opposite and adjacent, we consider the angle of reference theta. Opposite is as far away as I can go on the triangle, and I always label that with an O. And then what I'm left with is the adjacent side, which just means beside. So our triangle can be labeled based on the angle of reference, and then our three trig ratios. S for sine, it's actually spelt S-I-N-E, which is why we say sine and not sin. Don't sin, that's bad. Sine of the angle equals, and the OH stands for opposite over hypotenuse. Second trig ratio is cosine. Cos of the angle is adjacent over hypotenuse, which is where the AH comes from. And the last one, TOA, stands for tan, full name tangent. Tan of the angle equals opposite over adjacent. I know this is review, but it's good to write it down again. Let's do two examples. The first one, I have a 32-degree angle. At least that's what I'm telling you. And I have a hypotenuse length of 11. And I have labeled my triangle A, B, C. And I am going to solve for A. Now I have some labeling to do. First of all, where is little side A? Triangles, by practice, are labeled with the vertices with a capital letter. Capital A, B, and C I've already done. There we go. And so the sides opposite, because triangle and trig are all about opposites, this would be little side A across the triangle from big A. Little c, little b. So if we want to solve for A, we want this side over here. I'm going to grab a different color. We're going to label the triangle as well with hypotenuse, opposite, and adjacent so we can set up our trig ratio. So if 32 degrees is the angle that I know, although I could find the other one, I'm going to stick to using 32 degrees as my angle of reference. So to label the sides, I always start with hypotenuse because that's the longest side, the side across from the 90 degrees. The 11 is the hypotenuse side. Little c is as far away from the 32 degrees as we can get. That's opposite. And therefore little a happens to be the adjacent side. If I want little a, I want adjacent. And I have hypotenuse. Which trig ratio uses adjacent and hypotenuse would be the C. So we're going to use the cosine ratio, and I'm going to set it up. I'm going to write what I had up at the top here. Cos of the angle equals adjacent over hypotenuse. In go the numbers. Cos of 32 degrees equals, adjacent side is the little a that I want, hypotenuse side is 11. I need to solve for little a. I need to get rid of divide by 11. So I'm going to multiply both sides by 11 before I touch my calculator. 11 times cos 32. Be careful when you use your calculator. Every calculator is different. But you need to make sure that they are in degree mode. And whether you type in cos 32 just like you read it, or you do 32 and then cos it, will depend on the manufacturer of your calculator. So let's type it in together, 11 times cos 32, and make sure we get the same answer. I got 9.32 as my value for little a, and that is reasonable. 9.32 is a little bit smaller than 11, but certainly proximate, so that would be a good answer. Let's try the second example. We decided to move it to have just a little bit more room. So we have a triangle with lengths 3, 4, and 5. That is a Pythagorean triple, so those lengths would work on a right angle triangle. We are asked to solve the triangle. And solving the triangle means finding every darn thing. So I have sides A, B, and C. So I have little side A, it's 3. I have little side C, it's 5. And I have little side B, it's 4. So I have those 3 lengths. I'm going to just write them down. To solve the triangle, I need to determine angle A, angle B, and angle C. Well, I've got one of those two. It's 90 degrees. So I need the other 2 angles. And we know that these 3 angles will add to 180. So I'm going to use a trig ratio to find one of them, and then add to 180 to find the other. You get to just pick which one you want to use. I want to solve for B. So B will be my angle of reference, and I'm going to label the triangle. 5 is hypotenuse side. From B, 4 is your opposite side, and the 3 is the adjacent side. I have all sides possible, so I could use any trig ratio that I want. I'm going to write down all 3 just for the practice, and then we'll choose one to solve with. Sine of b is opposite over hypotenuse, which is 4 over 5. Cos of b is adjacent over hypotenuse, 3 over 5. And tan of b is opposite over adjacent, which is 4 over 3. You can use any one of the 3 ratios you wish to find angle B. I'm going to use sine. So sine B equals 4 over 5. How does one find an angle when you know the ratio? Well, I want to get rid of sine. To undo sine, you have to do the opposite of signing something. That's second function signing. I don't know that that's a verb, but we're going to do that to both sides. That leaves me with b on the left side and the second function sign or inverse sign of 4/5 on the right. Most calculators, you type it in like you see it. You need the second function button of sine, make friends with your brackets, 4 divided by 5. Angle B is approximately 53 degrees. So that leaves us with angle A as 37 degrees because they add to 180. So you have some practice with trig. You have a handout that I have in class for you to work on for the rest of the period.